Greetings, Patrick here from the Xyna team. This video will introduce the most important Zeta components for building a website that connects with Xyna. In the previous tutorial, we used plain HTML elements for displaying a list of vehicles. This time, we're going to use a component from the Zeta library. The names of Zeta components have the prefix XC. In this case, we are using an XC table. XC tables can get their data either from local or remote data sources. In this case, we add a table with a remote one, meaning it's getting its data via a workflow invocation. Additionally, there are numerous parameters to configure aspects, like whether the entries can be sorted, filtered, etc. To create a remote table data source, we need the API service for remote calls, the A18N service for localization, the runtime context to specify where the workflow is located, and the full qualifying name of the workflow. The called workflow doesn't only return the data to display, but also determines the columns to show and applies the filtering and sorting. For that to work, it must meet specific criteria. The first input and the output have to be of the type table info. It's contained in the Xyna application Zeta framework, which we hence need as a workspace dependency. Table info is used to specify information about the query, like column filters, and to return metadata about the result. Additionally, the workflow must return a list of the type that represents entries in the table. In this case, we use a vehicles array. A workflow with a described signature is often referred to as a table info workflow. How do we implement a table info workflow? When the GUI loads the corresponding table for the first time, it calls the workflow with a bootstrap parameter in table info set to true, meaning it needs to be initialized and augmented with information about the columns to show. For this purpose, the first call should be the service build table info and select columns. The service gets the current table info as an input, as well as an instance of the data type the table is supposed to show. Lastly, it gets a definition of the table columns. Let's build that last parameter with a mapping. For every column, there are the following parameters to define. Name is the key for the localized label in the GUI. You're free to name them as you see fit for your project. Here we have a vehicles table with a column model, so we give it the name vehicle model. Path determines which member of the vehicle data type contains this info. All the other parameters are optional. We can set an initial sorting via sort. Let's make the table sorted by this column, so we set it to ASC, which stands for ascending. DSC would mean descending sorting. For more details and an explanation about the remaining parameters, see the Xyna wiki on GitHub. For the other columns we want to have in the table, we add entries to the table column array in the same way. Let's add ones for the manufacturer year, mileage, price, and registration number. When adding the ones for the variables of the complex member type, drive type, we have to specify the path accordingly. Additionally, in our vehicle object parameter for build table info and select columns, complex members we want to query must be initialized. To query the vehicles, we need another step. Build query parameters from table info. Using the table info object, it creates the parameters for a query step. We use a variant of a query that takes these parameters. Now let's check our website. We get a table with the desired columns showing the stored vehicles, and we can sort and filter the columns. Yay! But the table headers still contain the keys for the labels. The labels are managed via the A18N service. This service helps in easily supporting different languages for our website. It's recommended to create translation files for every supported language in a subdirectory. Let's create one for the English labels. To that end, we create an array of the type A18N translation with a key value pair for every language key. Translations can also be structured in a hierarchy. For more information about localization, see the Xyna wiki and the upcoming tutorial about this topic. Let's set up the I18N service to always show the GUI in English and use our translation files for the English version of the GUI. When we check the results, we see that the column headers are now showing the correct labels. Now let's add a detail view for selected entries. This can be done with use of the Zeta component Master Detail. It consists of two parts, each wrapped in an XC panel. One of them gets the attribute master and the other one gets detail. The component XCPanel is a container to structure coherent data. We also need the directive XCMasterDetail opened. It opens the details, then the referred variable is set. Let's set this variable to the selected entry when a row in the table is clicked. In more complex cases, we would create an additional workflow that fetches detail data that is not shown in the table. That workflow would then be called when clicking a row to fetch the details. We move the table into the master panel and add a temporary placeholder in the detail panel. We also add the attribute XCTableAllowSelect. Now we can see our placeholder detail view when clicking a row. Let's add actual data to display. To that end, we use another XCPanel. The component can have a header, section, and footer tag. We use a header for the title and show the car's details in the section using an XCForm input. It gives us a label input field that can be styled. It also supports localization, but for simplicity, we enter the labels directly in here. Using the attribute readOnly, we can mark the labels as unchangeable. Now we add a footer section with a button. We could make the details changeable and add a save button, but saving will be covered in a tutorial about Zeta services. So for now, we just add a close button. It calls the given function when clicked, which we implement so that it closes the details. Those are just a few of many components Zeta provides. Here are a few more examples. An XC tree is used to show a data hierarchy in a tree. The sub-elements support collapsing and expanding. Entries can be changeable or read-only. The user may add or remove entries in the tree via the corresponding buttons. Values that can be entered might be free text or from a predetermined set. Like a list, the component gets its data via the concept of Zeta data sources. In this case, it's an XC3 data source. The Zeta component XC from autocomplete is a versatile drop-down menu. It supports full-text search within the set of possible entries and autocompletes entered text in real time. Optionally, it can also accept free text values. Furthermore, Zeta has basic GUI elements like the XC checkbox, which also supports an intermediate state in between checked and not checked and can be styled to fit the needs of a specific GUI. An XC canvas is the Zeta version of an HTML5 canvas and provides additional functionality. It works by the principles of the game loop pattern. The XC plot component can be used for displaying plots. It comes with versatile functionality and the appearance can be adjusted with custom styling. This video doesn't cover all Zeta components, but some additional ones are the XC tab bar, which is used for tabs and website, and the XC stack, which is a powerful tool to stack subpanels. Like an XC master detail component, it can be used to show details at the right-hand side of another component. But there can be any number of additional panels to the right of it, being handled in a stack-like manner. There are more Zeta components for basic functionality, like showing icons or tooltips. For more information about the mentioned and the remaining ones, refer to the wiki on GitHub. Now it's your turn to experiment with websites using Zeta components. Enjoy and feel free to contact us if you have further questions.